What is up, Math Maniacs? This is section 1.2, day 2, so it's 1.2b. That means evaluate and simplify algebraic expressions. This is your boy, Mr. Bergman. Like and subscribe. Here we go. Terms that are written about without a coefficient have an understood coefficient of 1, meaning if you see this, it really means this, and if you see this, it really means this. So let's get good at combining like terms. What are like terms? Like terms are terms that have the same variable part. So and constants are also considered like terms. So for example, if you see this right here, now remember, there's this p is really the same thing as a 1p. The like terms are going to be the ones that have the same variable part. That's the first one here and the last one here. Um, so you can see if what we really need to do is combine the 5p squared and the minus 2p squared. And in order to do that, subtraction just trips people up every day of the week. So I'm going to change the subtraction to the addition of the opposite. So I'm going to keep the p, change the subtraction to addition, and flip the positive 2 to a negative 2. 5p squared plus p plus negative 2p squared. Once it's an addition, it's going to be a lot easier to see that, the 5, and you've got to add the 5 and the negative 2. 5 plus negative 2 is 3. 3p squared plus p. You might think it's easier just to think about like 5p squared minus 2p squared is 3p squared. And you'd be right if you want. But I want to show it to you that way just to give you the option. All right, next problem. So here you can see just a whole lot of I'm going to change the subtraction to the addition of the opposite. So this subtraction, keep everything here, keep, change, flip the 4 to the negative 4. And now when I distribute, it's going to be a little bit easier to think about. So 3 times y plus 2 is 3y plus 6. Remember to multiply the 3 times the y and the 3 times the 2 to get the 6. I'm going to distribute over here also. Negative 4 times y is negative 4y, and negative 4 times positive 7 is times negative 7 is positive 28. And so now I'm going to combine the like terms. I see the 6 and the 28 I can combine, and the 3y and the minus 4y. 3y, 3 plus negative 4 is going to be negative 1. Negative 1y. Plus 34. How about over here? I guess the first thing we got to do, we really can't combine terms with their, if they are inside parentheses. You got to get rid of parentheses to do it. So we're going to distribute. This becomes 6xy squared plus 7xy. Now you might be like, Bird, can I write 7yx? And can I, like, do I kind of put the x out here first? And technically, you'd be able to. Like, mathematically, if the overall answer to a different problem were like 7xy and you put 7yx, flipping the order, they're mathematically equivalent to each other. They're not going to get you marked wrong for that, neither in person and paper with me or even on online systems where you have to type in 7xy. You could type in 7yx, it doesn't matter. However, I will say that from a studentship point of view, it's a lot easier to keep track of stuff if you keep it all in alphabetical order. So if you wrote 7yx here, and you wrote 7xy here, if the two were flipped, you'd be like, wait a minute, I'm not sure if we can combine them or not. And when in actuality, you can. So not because of math, but because of studentship, I think it's a lot easier to alphabetize all your variables. Keep x, like in this case, x comes before y in the alphabet, and you can see in all these terms, I'm writing xy, xy, xy. All right, so now that I've done that, I can do a better job. I can see what I can actually combine. 7xy minus 7xy turns into 0. And then what is 6xy squared plus 9xy squared? It's going to be one term, and I want you to tell me what it is there. All right, you are selling homemade candles at a craft fair for $3 each. You spend $120 to rent the booth and to buy the materials for the candles. Write an expression that shows your profit from selling key candles. Okay, so word problems. I know there's a lot of moaning and groaning around people with word problems, but you know what? If you ever actually see a word problem in real life, like math comes at you in word problems, and sometimes they don't give you everything you need. It's way messier than even the simplified word problems that you get here. So let's get good at word problems because that's actual real life. So And the way that I'm going to recommend is that we use the same format that we had for physics. I hope you practiced it well. It's the GUES. Practice it well freshman year, because now sophomore year is going to be GUESS. Givens, unknowns, equation, simplify, and solve. No, solve and solution. That's what it is. All right. So anyway, givens. We've got $3 each. That's what we know that for sure. And the total cost for everything is you spent $120 just setting this whole thing up. What is unknown? And here's the most important part of the whole thing. You gotta write out the unknowns, because if you don't make clear in your head what the unknowns are, how are you gonna possibly solve an equation? This is the one step. I don't often say that things are easy, but this is literally the easiest thing to do out of GUESS, and it's also the thing that people forget to do the most, and that's why people think that word problems are hard. Or harder than they really are, because you can't forget to think about your unknown. So actually think about it and write it out, please. When you're doing work in my class, I'm going to ask you to write GUESS, so that you can get in the habit of thinking about the unknowns. In this case, they tell you what the unknowns are. They won't always do that, but they're trying to help you out and say, all right, don't forget, what you don't know is the number of candles. So that's what you write out. Then, now that you have all this, you can write some sort of an equation. You can say that the profit, we have a profit. This idea comes from economics. Profit, the amount of money you actually make on a whole venture, is going to be the revenue. That's like the money that's in the cash box, the money that you bring in, minus how much you had to pay at the very beginning to get the whole thing set up. It costs money to make money. It costs $120 to make all that revenue that you made. So what that looks like is the cost was $120. That's how much you had to front at the beginning. The revenue is going to be $3 each candle. We don't know how many candles. We don't know how much profit, but this is good for right now. Now, the next part would be, what if you find the profit if you actually sold 75 candles? So they're telling you, oh, wait, C is going to equal 75. So your profit's going to be $3 a candle times 75 candles you sold total. That's a lot of candles you're out there at that craft fair. You working hard for those 75 candles selling. And then you had to front $120 at the very beginning. So how much profit are you actually going to make? When you multiply and subtract, you get that you actually made $115. Go you. All right, now this would be a good time for me to drop your audio check. When did I meet my now wife? When did we start dating? I'll tell you what grade we were in. We were senior year, 12th grade, and it was a wonderful time. Tell you more about it in class, but that's your audio check. When did I meet my wife? 12th grade. You sent 15. Oh, and we dated all through college too, and we went to different colleges. That was rough. Do not recommend unless you super in love. All right. You send 15 digital images to a printing service that charges 80 cents, $0.8 per print in large format. We also got the small print version, which is 20 cents. Write an expression for a total cost if there are 15 total prints and n of them are in large format. Oh my gosh, there's so much to organize. What's going on here? Let's get organized. G, givens. That's 80 cents per large, 20 cents per small, and a total of 15 images. Some of them are going to be large and some of them will be small. What we don't know is the number of large. It says it right here, n in large format. So an equation is going to be the total cost and the cost of the larges plus the cost of the smalls. Okay. Now, the cost of the larges is going to be n. We don't know how many n larges there are, but we'll just use n here, and that's how much it costs for each of them. So 0.80 n plus the cost for the smalls is 20, and I don't know how many larges there are. I don't know how many smalls there are, but all right. So as I was saying, it was 20 cents for every small image. But as you can see, we don't know how many. We don't have a variable for the small images, and we don't know how many. But we do know that there's a total of 15. So actually, what you can do is you can represent the number of small images as 15 minus n. Whatever the leftovers. If there's n large, then 15 minus n would be the smalls. just whatever's left over. So the total cost is therefore going to be, and then it says, find the total cost of 5 of the 15 prints are unlocked. Now they tell us that n is equal to 5. Okay, so you can see n turns into 5, and 15 minus n turns into 10. You find the total cost, grab a calculator if you like, and that turns out to be $6. Great. So thanks for paying attention, thanks for taking notes, and I'll see you in class.